Attendance. I am Ugaz, my avatar is Maximo Eames. This is a research in progress model for effective collaborative learning in virtual worlds with intelligent agents. I will start with an introduction. Virtual worlds appeared in the mid-90s. Its diffusion and global recognition starts in 2007 with the popularity of Second Life in the blog Medical Library Tech Trends 2007 as part of technology trends. And the first was precisely Second Life. Virtual worlds are part of the broad field of shared spaces technologies with augmented reality, telepresence, and virtual reality. All discrete spaces represented and executed by computers which are accessed exclusively through the internet. On virtual worlds, people interact through their avatars. The process of knowledge is managed by the users themselves through their avatars, through new ways to transmit and share information on a global scale, in an apparent local environment, generating collaboration, networks, and information ecosystems. Virtual worlds like Second Life have limitations to its massification because of the significant hardware and software resources that requires to those wishing to use them. However, there are many promising applications of these virtual worlds, including distance education. The research by reviewing the state of the art of virtual worlds, the intellectual capital, collaborative knowledge management, intelligent agents, and MPLM 3D platform proposes a model of how the capacities of virtual worlds allow getting an effective collaborative in learning and experimenting with agent avatar interaction in Second Life, which can answer, for example, frequently asked questions from the participant avatars. The state of the art includes the area of 3D virtual worlds involving intelligent agents and collaborative learning with emphasis on the environment and interactivity. Its content draws on two sources. First, experiences in Second Life virtual worlds, and second, intellectual capital and collaborative knowledge management. Intellectual capital is everything that cannot be touched, but it can make money for the company, says Benavides. Intellectual capital is the search for effective use of knowledge, represents the collective intangible assets that can be identified and measured. Is the set of company assets, although not reflected in the financial statements, generate or will generate value for it in the future. As a result of aspects related to human capital and with other structural as innovation ability, customer relationships, quality of processes, products and services, cultural capital, and communications that allow to a company to take a better advantage of the opportunity than others, resulting in the generation of future benefits. Intellectual capital is a product of the interplay of human capital, knowledge workers, the ability to learn and adapt, etc. Structural capital, trademarks, patents, copyrights, product names, and other assets, intangible internal process and research and development, etc. And relational capital, business relationship with customers, suppliers, distributors, investors, and other stakeholders, government and society in general, which is reflected on the ability of the human talent to add value not only to tangible assets but also intangible assets of an organization and generate or will generate future value of which you can consolidate a sustainable competitive advantage over time. Furthermore, we analyze the model DIRCCI, Collaborative Management of Intellectual Capital, where from the perspective of intellectual capital, a way of integrating collaborative business rules is presented. Bernuy presents, first, the address of an entity, second, indicators of intellectual capital as a result of learning, third, the environment that always releases changes or delivers rules of play, a collaborative system as the main component that instructs, shares, and supports the decisions. This new system is based on agents and processes of transformation from human resources to structural capital and relational capital. This is when the organization creates knowledge, and the most important elements are the innovation, competitive skills, and human development. Transformation processes are studied in other research called intellectual capital navigator. The transformation is based on rules we call workflow. Now let's include the context of internal and external environment as the main contribution of our research. Virtual worlds. The predecessors of virtual worlds were role-playing, multiplayer online, MMORPGs. Massively multiplayer online role-playing games, such as EverQuest or World of Warcraft. The difference between virtual environments and 3D games is that there are no rules. There is no objective or overcome phases. The actions to be taken are set by users according to their interests. Meet people, do business, promote your products, model in virtual environments, etc. For us, it's an opportunity to create new application environments. Different authors define virtual worlds as computer-simulated environments that users can inhabit and in which they interact with others, either themselves or through agents or graphic software called avatars. Second Life is an online virtual world owned by Linden Labs where users can build their own environment, interact with each other, and even start a business model. It has its own currency convertible to real currency. It is currently the market leader in virtual worlds and has been used from the beginning for meetings or teaching classes and lectures, especially from developing their voice module. Universities around the world rush to open their virtual installations in this environment, although usually more for advertising than with a true vocation to use it as a virtual teaching tool, as says Barreiro. The membership of Second Life, one of the most recognized metaverses, has increased more than 20 times between 2006 and 2009 to reach 50 million, as says Bell-Lisle. Collaborative knowledge management requires create synergy in organizations in order to capture the knowledge in the people. The users needs to implement the effective collaboration between them. Intelligent agents and multi-agent systems, MAS, are aligned to distributed systems that enable interoperability, communication, security, migration, and proper management of the environment and the necessary dialogues in virtual worlds. The Intelligent Distributed Control System based on agent SCDAIA allow collaborate. First, measurement agents collect the information needed to get the status of the process. Second, controller agent take actions based on the state of the system. Coordinator agent modify control agent decision and sets new goals and services. coordinates the agent community. 4. Actuator agent implements the decision taken by the controlling agent, a coordinator, and or specialized agent. And 5th, specialized agents, they perform special tasks of the community of agents. On the other hand, a multi-user virtual environment, MUVE, such as Second Life, can be a great tool to educate people and to do research in a way that people learn. The use of automated agents conversation with artificial intelligence capability can develop more interaction with people from identifying their human and emotional profiles. They can be used to tutor the students, and they can be used to manage or orchestrate consistently environments for research purposes, as say Coffee et al. In this example, Second Life architecture middleware component shows its interaction with the object and the Basilica conversation agent, scheme to facilitate the rapid development of conversational agents involved in collaborative environments. Every time there is a new object in the front end, an instance of a user is created. The object is connected to the middleware to start a new session. The new session period indicates to the conversational agent to generate a new instance of itself and act as a second order of the session. From here to middleware receives a message, translates the message, and the messages are sent from one object to another. It's in this way how virtual worlds and Second Life work with intelligent agents. Therefore, we analyze them with a focus on collaborative knowledge management. An intelligent agent is a software that assists clients and acts on their behalf. A sovereign entity that, based on their own knowledge, performs a set of operations to meet the need of a user or another program, whether on initiative or any of these are required. Computer programs are capable of performing a task or activity without direct manipulation of a human user. Agents have to learn the essential characteristics of different ways, by observing and imitating the behavior of the user. Second, receiving positive or negative feedback from the user. Third, receiving explicit instructions. Fourth, asking advice to other agents. According to Bernuy-Alva, among the features that agents have, highlight be endless processes that run continuously, be able to act based on their experience, and be able to move through a telematics net. For us, agents have new challenges in the design of an environment that includes the proper characteristics of the people environment and their personal characteristics and cultural patterns. We analyze the classification available for our research. The available classification field of actions: desktop agents, internet agents, intranet agents. By function, system agents, filtering agents, profile agents, monitoring agents, recommendation agents, and others. From these intelligent agents, we point out three of them that are related to the topic. First, recovery, looking, recover, and provide information as authentic information managers and documents, information brokers. Second, monitoring, give information to the user when a certain event occurs. And third, recommendation, help users in three dimensions: informing, filtering method, demographic, content-based, and collaborative. Profile correspondence when are based on the content and the user, matching collaborative techniques. Collaboration and team learning in virtual worlds. Increasing competition, globalization of markets, and the casual geographic dispersion of the organizations make it increasingly more important for organizations to enable team collaboration regardless of time and place. With the advent of worldwide connectivity through internet and digital technology, the use of virtual teams, because of its feasibility and cost-effectiveness, effectiveness it's becoming commonplace in organizations. Virtual teams are teams that work together on a common task, regardless of geographical boundaries, temporal and relational, supported by information and communication technology. The potential of a medium as rich and attractive for knowledge sharing and virtual collaboration has been recognized by professionals and scholars. Despite this increasing focus on 3D virtual environments in the literature, less attention has been paid to how the unique capabilities of 3D virtual environments could affect virtual team collaboration. For effective team collaboration, two types of communication tasks must be performed. First, the information about the task to be transmitted and processed by the individual group members, a process known as information carrier. Second, group members need to communicate information related socially and need to reach a common understanding on the basis of information processed individually, called support communication. Van der Laan et al. Indicate that up to now there is no theoretical model of 3D virtual environments that takes into account the unique capabilities of the media in the 3 virtual environments to support these two processes and present a theoretical model focused specifically on the effectiveness of collaboration in 3D virtual machine. We propose that the component where the information must be transmitted has an improved recognition of relevant information in each process. One of the features of 3D virtual environments that enable team collaboration support is avatar-based interaction through which all communication is carried out. In 3D virtual environments, people are represented by avatars, virtual representations of themselves in a variety of ways. Avatars are digital representations of identity. The avatar-based interaction is a rich form of interaction in which team members can use a variety of communication signals such as text-based, chat, audio, pre-recorded animations, for example, dance moves, gestures. Two related capability, avatar-based interactions can support collaboration in virtual environments. Social presence and control over self-presentation through the ability to manipulate avatars. Lean proposes 6 learning frames designed for virtual worlds not seen as hierarchical or mutually exclusive. These are learning through exploration, learning through collaboration, learning through being, learning by building, learning by defense, learning through expression. Of these, learning through collaboration occurs, for example, when students work in teams, whether in problem-solving tasks or other forms of structured research in academic environments. The literature shows that the capability of virtual worlds to support team collaboration are based on two unique features of these, namely, first, the 3D environment itself in which participants are immersed, and second, the avatars-based interaction through which all communications in virtual environments are performed. On the other hand, we also show that there are different approaches to exploit the collaborative possibilities of virtual worlds in e-learning. E-learning through collaboration is one of them, and it is what occurs when people work in teams, for example, solving problems or researching. Our proposal is that the capabilities of virtual worlds for collaborative teams can effectively support collaborative learning. The problem is defined with a question: in which measurements the capability of virtual worlds to support effective collaboration in teams support an effective collaborative learning in these environments. We propose an adaptation of the effective collaborative learning model in 3 virtual environments with the hypothesis that immersion in 3D environments and avatars-based interaction of virtual worlds effectively support collaborative learning. The model proposes that the capability of the 3D environment and interaction-based avatars have a proven effect on the two supports shared keys to understanding. They support information processing and communication support. In these capabilities of 3D environments, if this capability of 3D environment have a positive impact on teamwork. We argue that effective collaboration in group can have a positive impact on collaborative learning. For us, the inclusion of identifying information agents allow to increase metacognitive habits as well as the understanding of distributed cognition and social dynamics in a particular context, achieving effective collaboration learning. We experiment with a group of teachers who entered presence to the virtual world for the first time, made the adaptation process to the 3D environment and began to participate through the avatar's interaction in terms of achieving a specific objective common in team, which was to develop skills through a workshop building and implementation, culminating in a draft of Second Life practical use. Effective collaboration group was shown to jointly acquire knowledge about the resources offered by the 3D environment. The communication process performed through the presence and identification with avatar social presence resulted in constant interaction with the virtual world during the workshop. In this way, the understanding and effective collaboration of the group resulted in an effective collaborative learning, since the group might be able to understand the use of the resources of the virtual world and likewise design, and build a personalized space to the objective of the team and applying simulation of practical use. The multimodal presentation markup language 3D, MPML3D, is a scripting language based on XML which enables to control of verbal and non-verbal behavior of agents in 3D. Comes from the original language MPML developed by Ishizuka Lab at the University of Tokyo. In 2008, the MPML3D was revised to support scenarios enriched in interaction with real agents in Second Life and OpenSim, becoming the first agents online scripting language in 3D world on internet. The MPML3D integrates to Second Life and is divided into two different sections. First, the MPML server, second, the official server cluster network from Linden Lab, and third, the client side of digital users of the system. Basically, the system requires an MPML3D script as input in order to allow users within SL avatars to interact with the script-driven agents, bots. To actually host an MPML3D based scenario within the Second Life, the content creator has to use the services that are provided by the MPML3D server. Potential users or visitors just need to use the free official Second Life client of software. The actual implementation is based upon the MPML3D framework, working with the MPML3D backend and making interface with the frontend server of the MPML3D of Second Life, all from end with optional clients which can be out of line. The MPML3D backend implements this scenario, the scene setup and the scene plot content, as defined in the MPML3D script, and acts as a host for one or more front ends. It integrates the parser for the XML-based script source with a dynamic runtime representation of all interdependencies between an hierarchy of agents, conversational activities and perceptions, the so-called activity network. In order to keep this part of the MPML3D system flexible, the back-end handles the scene entities and activities on a consolidated route, leaving the current implementation effective of the interface. Implementation with an agent avatar in Second Life based on MPML3D. MPML3D languages handles the interaction with an agent and must have been previously created in the virtual world. For our experiment, we created an agent avatar named Albert Milodanic. The avatar in Second Life was created following the process of creating customized avatar, no matter if it's used or not as an agent. We use an adaptation of user input npm-l script that comes with the installation of npm-l3d. It states the agent, the location should appear in Second Life. You set property to listen and action to be followed by the agent when hear the instructions in the virtual world. The agent will listen through chat commands that are sent by the avatars who are in the position where it appears. The action were defined: greetings, and your node, go to east and go to south. The backend runs in a command window on the computer where the server is installed. The run line is through the Java virtual machine using the command java jar backend, etc. Once of the service is charging, backend is ready to run services from different agents in different virtual worlds. The agent avatar is loaded by running the service slfrontend.exe, and the agent appears in the defined position within virtual worlds. The agent replied avatar without inconvenience to the commands sent by other avatars present, driven by human via chat, such as hello, go north, go south, go east, go west, and bye. In all cases, the agent performing the action foreseen in the script, respond by chatting and execute movements, some steps, to the addressed list. In the following video, we will be able to appreciate the experiment we have described. The participants are intelligent agent Albert Milodanic, and the person avatars are Maximo, Eames, and Almendra 2012. Amparo will give you the instructions.
Yes, just a second, please. Okay, you have to click on the screen and then click on the play button, please.
The first thing performed by the intelligent agent named Albert is to make contact with the npm-l3d server. Then it got an order that involves a gesture and a text. In response to the person avatar greeting, the agent Albert greeted through the text chat with the phrase, "Hello, I am to serve you," and made the gesture of greeting. Then a second order was given. It was a farewell. The person avatar wrote, "Goodbye," and Albert responded, "Bye, be back soon," and made the gesture of clapping. Then some move orders were given. The first one was to go to the south. The avatar person used the text chat and wrote the order, "Walk to the south." Albert answered quickly in chat, "Okay, I go to the south." We can see the displacement of the agent. Similarly, the command, "Walk to the north," was given and Albert answered, "Okay, I go to the north." These orders are processed outside of Second Life, but the commands are given within Second Life through text chat. Then he was ordered to move to the east, walk to the east. Albert replied, "Okay, I go to the east," and moved. Then is commanded to move westward, and then with a final order the agent moved to its original location. With this experiment we are showing that it is possible to control an agent avatar being in Second Life, but through external servers that allow scripts to process the command and execute certain actions based on the perception that occur within the virtual world. In the control sequence diagram of an agent in Second Life by npm-l3d, we can see how the backend, frontend, and Second Life work to manage the agent actions. The backend runs the script, the frontend connects to the backend, and it communicates which avatar is the agent and the scenario, and from there, the frontend communicates with Second Life. In this case, there are previous scripts uploaded, does the logging of the agent avatar and communicates to the front end if it was successful. Perceptions occur in Second Life. For example, when we wrote the commands, it was made from the same in Second Life. These perceptions are sent to the front end and then tell to the back end, which has loaded the script. This will determine what action is to be executed. That execution is indicated to the front end, which in turn communicates to Second Life what should be represented or what actions should be taken, and so on. We enter in a kind of loop through perception that occur. In this case, the command that were typed, which not need to be only commands, but also gestures to which the avatar agent will react.
Okay, thank you. As we have seen, the experiment showed that the language MPML3D allows a variety of communication possibilities with an agent avatar in the virtual world. This is where we present our vision of a learning model that helps productive for women with disabilities in order to support productive context and health that help strengthen a life based on freedom and development approaches. Our conclusions and future research: virtual worlds have their own abilities that differentiate them from other forms of interaction. Among them, the 3D environments and avatar-based interaction can withstand the processes required for effective collaboration in teams. The officers have enriched the collaborative interaction among other reasons because they can mimic the behavior of the user and we can adapt to your environment. Effective collaboration in teams in virtual worlds through collaborative knowledge management can lead to an effective collaborative learning. Through NPM L3D platform can be achieved easily shaped intelligent agent within Second Life avatar that can enhance learning in virtual worlds with avatars interacting handled by people. The convergence of knowledge management, intellectual capital, intelligent agents, and virtual worlds allow effective collaboration, encouraging the transfer of knowledge of effective learning. Thank you very much. Thank you, thank you. Okay, Jerry. Do you hear me, Jerry? If you don't, I can. Okay.
I guess a question, especially since you and your team have worked on the much closer to the technical side of these things than I typically encounter or delve in myself. I'm wondering what your perspective might be about how soon or how viable it may be to utilize motion capture and visual capture, like through a webcam and things like that, systems like that, and have that translate into more natural nonverbal behavior for avatars in worlds like Second Life.
Oh, yes, great question. Yes, I understand. I have been trying to search if there is some other research in the internet, in the world about that. This platform works also with voice, but voice executed by the avatar. The avatar cannot understand by the moment in this platform, for example, voice orders. You have to use chat. But it depends in part from the capabilities of the scripting in Second Life, because from the other side, if you get the information from Second Life, the scripting has a lot of libraries that allow you to create any kind of responses. The restriction is in Second Life, in the API in Second Life by the moment. I don't know if some other researchers are making some progress in that line. Is that okay? Okay. Yes, I guess, Lord one. We have been working in the chat mode because we have to be very focused. And we are starting to manage the agent. We expect to find in the future other researchers that are working more deeply with the Second Life API.
Just a really quick comment, sort of related to that.
Yeah,
I mean, I've been working in exploring this environment probably for a little over a year, or maybe two. Really interested in the potential of it as a kind of a virtual third space or a co-working space. So just not just some place to kind of show up and hang out in, but to have an environment that was functional and that would facilitate human interaction in a fluid way. And that's one of the things I've found that's been a limitation, is the loss of the nonverbal cues in the environment, and having that really kind of slow down interaction and processing, just on a very, very fundamental level of just being able to communicate with one another. Never mind just functionality within the environment, things like presentation screens and other things that you can maybe get the environment to do as a tool, but just as a basic communication and interaction platform. I've found that to be again, that kind of expression of nonverbal behavior to be a kind of a limiting factor in how fluid the interaction can be, especially if we end up being restricted to text.
Oh yes, great. It's very interesting that you have been researching. I understand with the platform, no? MPLD3D. What we want to do is we are not working specifically in the platform to research more ways to communicate. What we want to do is use the chat to allow teachers, professors, non-native teachers in Second Life to have some kind of assistant who can answer quickly and move from in the learning space to tell, for example, students where are certain materials or issues about the course. That's what we are trying to build. No? I understand that there are many other possibilities. That's the fascinating thing around this intelligent agent in Second Life. Using the intelligent avatars, no? Because sometimes for professors that are not native and they without many experience in technology, they have problems to interact, and the students feel that they need more information from the professors. So the intelligent avatars could enrich the experience of the students in these virtual spaces in Second Life.
Yeah, I guess from the perspective that I'm kind of approaching this from, I kind of see potential in the scripting that you're doing for the intelligent agents, and that once that's developed, I mean, there must be a way to code or match that to alternative input, from a live user. So for me, those are the kinds of things that are sort of percolating for me, listening to the things that you're talking about. But thank you.
Great, thank you. Any other question? Okay, Laurie, I think. Okay, I didn't read it. Can you type it again, please, sweetie pie? Sorry if I didn't read it. Maybe. No, it's my pleasure. Amparo, did you get
Yes. The studio, request.
Can you copy it? I was asking if notecards would be a tool to use in communicating with the students. In this case, of course, we use notecards very much. I think it's a fundamental tool in Word. But in this case, not bad. In this case, the intelligent avatars can deliver the notecards, the proper notecards for the proper questions to the students. So we can combine notecards with intelligent agents in Word. Is that okay, sweetie? Sweetie pie? Okay. Thank you very much. I really appreciate your participation, and I hope to be in contact with you. Bye. Thank you, studio. Thank you for that. And of course,